Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I'm Uncle Agbaje. Our topic for today is a very simple one. We'll be looking at value and place values in numbering system, and I'm sure that you're familiar with it, so let's just assume that this will be a sort of revision class for you. Moving on to today's work. When we are counting quantities are things that can be counted or measured, like oranges, like your pens. In this case, I'm going to use a square. When you're counting quantities, we use single digits to begin with. Start with 1, so that's 1 square. Then now you have 2 squares, and then you have 3 squares, and then 4, and then 5, and then 6, and then 7, and then 8, and then 9. And here is 9 small squares. Now, after you get to 9, you still want to add more. You cannot have a single digit to represent all of them after the 9 count. You cannot have just one single digit. I mean, in our numbering system, we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. These are the single digits we had, and it is these digits that we combine to form numbers. So we don't have a single digit to use anymore. So what do? We need to add more. So by adding more, we need to reuse the digit that we have already used. We have to use 1 all over again, okay? And so this 1 comes here, but this is a problem. This is not correct because this 1 is representing 1 square. We cannot use the same 1 to represent all these squares, 9 and another 1 square. No, this 1 cannot be here. And so this 1 represents 10 single squares, okay? So we can't put it here because there's no way to differentiate this 1 and if it is 1 square. So what we do is that we move this 1 to the next place, the next position. Remember that each place value has 3 rooms. Well, you move it to the next room, and then you had 0 here to differentiate between 1 single square and 1 10 square. So you can see that all the squares have come together, and you have 1 long strip. So this 1 means 1 long strip of 10 small squares. So you have 1, and this is what you call 110. Okay, this is 110. So we'll put a 0 in the unit place, just to hold the place. It doesn't have a value of its own, but the 0 is just to hold the place. Otherwise, if we just put 1 here, it's the same thing with that 1 for 1 square. But if you want to show that it is 10 small squares, put 1 in the next place, and then it's 0 before it. So this 1 that is here is not the same thing as the 1 that is here. And the 1 that is here will not be the same, will not have the same number of squares as the 1 that is in the next place, as you will say. So if we count by 10 singles, okay, so now let's say this is 1, and you can see that this is 1 long strip, and I did not put it here because it's not talking about 1 small square, it's talking about 1 strip of 10 squares. So I put it in the next place. So if I bring 2 strips, that's 2 strips of 10 squares. So you can see I'm counting here now, I'm not counting here again, okay? And I have 3 strips, and I have 4 strips, and 5 strips, 6 strips. So this 6, when you see it, it does not mean 6 small squares. It means 6 long strips of 10 squares. That is 10 in 6 places. That is what this 6 means. And that's why you have a 0 holding the unit place. Okay, so then you have 7, 8, and then 9. And now we're getting to that 9 again, and there is no digit after 9. So we have to go back to use 1. And in this case, we have to use 1 again. But that 1 will no longer be here to move to the next place. Okay, so now this 1 again now, this 1, it does not represent 1 square, 1 small square. It does not represent 1 long strip. Rather, what it represents is 1 big, square like this. And inside this 1 big square, so you have 10 strips, and you have 100 small squares. So this 1 actually means 100, and that is why we use that 100 tens and units in our primary schools, to help us know that the 1 here is not the same thing as the 1 here. The 1 here is not the same thing as the 1 here. They count different things. So this 1 box here represents 10 strips of 10 singles. So this is 1 strip of 10 singles, 1 strip of 10 single squares, and you have 10 strips of 10 singles. And altogether you have 100 single squares in here. And so that's what this 1 represents. It represents 100. So the position will now determine if it is here, it is representing just 10 singles. If it is here, it is representing just 1 single. All right. So each digit in the number stands for a particular value. When you have 3, 5, 2 like this, it does not mean 3 squares, 5 squares, and 2 squares. No, this 3 means 3 big boxes, or 3 big boxes, and that is 300 because inside one box you have 100 squares. And that 5 means 5 long strips, as you will say. 352 means 300 singles, so you can see 100 here, 100 here, 100 here. Altogether, there are 300 small squares. That's what this 3 means. But that 5 doesn't mean this. It means 5 long strips. And inside each strip, there is 10, 10, 10, 10, 10. So 10 in 5 places, that is 50. And then these 2 means just 2 singles. So if that 2 were to be here, that would be 2 long strips. And if that 2 were to be here, it would be 2 big boxes of 100, 100 each. So I believe you get the idea that these digits, they mean different things depending on their positions. All right, good. So let's go. So what's our learning objectives for today? By the end of this lesson, you should be able to appreciate the difference in the value of digits. You can already see that digits have different values depending on where you put them. Okay, so you should be able to appreciate the difference in the value of digits, and then you should be able to find the value of each digit, especially in large numbers. You should be able to tell us, okay, this digit is in this position, then this is the value. Okay, it's in this position, then it has another value. Okay, and finally, you should be able to manipulate the values of digits to perform basic operations. Let's see how that goes. So now we're going to move on to the value of digits in large numbers. Don't forget that we've taught large numbers in our previous lessons. We talked about thousands, and we talked about millions, and we talked about billions. Then we talked about the trillion. So these are what we call large numbers. Okay. So finding the value of digits in large number is very, very easy. Means this is one of the easiest aspects of math work that you will come across. So just follow me, and I'll show you how easy it can be. We will simply find the position of the digit, and then every other space to the right, we fill it with zeros, just like we did in the previous slides. If you move 1 to a new position, you fill the previous position with 0, and then you get the value of that digit. So let's see how this is done in real time. This question says, find the value of each digit in 6,521,428. Okay, you have to find the value of each digit, and in this number there are 1, 2, 3, 4, 5, 6, 7. There are 7 digits. So what we do is we bring down each digit and find the value. I hope you remember how I said we're going to find the value. We'll find the location of each digit, and then the remaining spaces until you get to units, you fill it with zeros. Let's see how that is done. So I'm going to build houses as usual to guide you, but subsequently I may not. I believe you would have gotten the hang of it now. Okay, so obviously the first 3 will go under ones, the next 3 digits will go under thousands, and the next one will go under millions. Okay, so I want to find the value of 6. What does this 6, what does it represent? So what I'm going to do is I'm going to bring down the 6. The 6 is going to come down. Now you say that to the right of 6 until you get to the last digit for the unit, there are 6 places. 1, 2, 3, 4, 5, 6. So I am going to fill the 6 spaces with 6 zeros. And then I get the value of 6 automatically. I mean, isn't that simple? The value of 6 is simply 6 and all the spaces beside it, 6 zeros. 6 and 6 zeros. But how do we pronounce this? Your 6 is under million. So you say 6 million. So when you're asked to find the value of a digit, well, if you write it as 6 and all the zeros beside it, you will be correct. But if you decide to write it as 6 million, that is 6 and million, mixing the figure and the words, you will also be correct. In fact, this is more preferable because it shows that you know it. You know, some students are very funny. They'll just write 6 and start writing zeros until their hands start aching them, then they stop. You know, teachers will want to count and see that you get the correct number of zeros. But if you want to prove that you know it, just write 6 in figure, then write the million in words. Okay, let's take a look at the remaining digits. Yes, the 5 comes down, and then to the right of 5, you have 5 spaces. 1, 2, 3, 4, 5. So you put 1, 2, 3, 4, 5 zeros. And how do you pronounce this number? Well, 500 here. Excuse me. Now 500 here falls under 1,000. And there is nothing after it. So that is 500 under 1,000. So you said that the value of that 5 is 500,000. You don't say 5,000. This is not 5,000 because it's in the 100 position on the 1,000. So you say 500 on the 1,000. So it's 500,000. So it's not 5,000. This is not 5,000. This is 500,000. Because if you were to build houses, this all 500 will be on the 1,000. Okay. So you say 500,000 is the value of 5. It's very easy, isn't it? So let's see the remaining digits. So you have 2 comes down, and then there are 4 spaces, and that means 4 zeros. 1, 2, 3, 4. And then 20 falls on the 1,000. Out of all these digits, 20 falls on the 1,000. So you say the value of that 2 is 20,000. So all you do is bring down the digits, put all the zeros, and pronounce the number. It's as simple as that. Let's see 1. 1 comes down, and then there are 3 spaces to the right. So this is just 1,000, of course, and you write 1, then 1,000 in words. But if you write it like this, my friend, you will still be correct. Let's move on. Then you have 4. And so the value of 4 comes down, and to the right of 4 there are 2 spaces, and that is 2 zeros. So that is 4 and 2 zeros. So you say it's 400. So you can mix the figure and the words, you will still be correct. And then value of 7. So 7 comes down, and then there is just 1 space, so you put just 1 zero, and that is, of course, 7 and 0 is 70. And now this one you need to pay attention to it. 8 is the last one, so it comes down, and there is nothing to the right, so you don't put any 0. The value of 8 is 8, and that means that if you write 8 like this in this position, it means 8 single squares. But if you write 7 in this position, it does not mean 7 single squares, it means 7 strips of 10 10 squares. So that is 10 10 10 10 strips in 7 places. That's why you get 70 squares. So what this 7 really means is 70 squares, and what this 4 really means is 400 squares, or singles, or units. So you have it. Now it is your turn. You have to find the value of just 3 digits. I do not want you to waste too much time. 4, 7, and 9 in this number. Only the values of 4, 7, and 9 in these numbers. You have just 30 seconds. Begin. Eyes on me. I believe that you have gotten your answer. So the first thing we do is we build the houses. Then I'm going to bring down 4, 7, and 9, she'll say. So 4 comes down, and then there are 7 spaces afterwards. So that is just 4, 1, 2, 3, 4, 5, 6, 7. So that's 4 and 7 zeros. But if I want to pronounce this number, I see that 4 and 0 falls under million. That is 40 million. I believe you got that. Of course you did, because you're very smart. 7 falls on the 1,000. So 7 comes down, and there are 5 extra spaces. Now to pronounce these numbers, in this number, I write 700 on the 1,000. That is 700,000. And finally, 9. Of course, 9 just comes down, and there is just 1 space after it. So that is 9 and 0, which is 90. Did you get it correctly? Good job, you. Now let's see something that we can do with our knowledge of these values. This question says, add the value of 6 in 46,315 to the value of 9 in 233,191. So what we do is that we are going to bring out the values of this number. So you see, the value of 6 in 46,315 is 6,000. And why is that? Because this is 6. So if I bring it down, I'll have 6 here. Then there are 3 digits after it. That's 0, 0, 0. So that's how I get 6,000. Okay. Now, the value of 9 in 233,191 is 90. I mean, this is 9. Bring it down. There's just 1 space. 9 and 1 0. So that is 90. So now to find the sum, or to add them together, the sum of the values is, now when you want to add, my friend, be careful here. You have to bring unit under unit. Okay, so you cannot just put 9 under 6 because this 9 does not have the same value as 6. 9 is under tens, 6 is under thousand. So you have to bring unit under unit, tens under tens. Then you do your subtraction, and I believe that you should get this answer 6,000. You do the addition part, I beg your pardon, and you'll get 6,090. Let's take a look at another one. You have to find the product of the value of 8 in 80,402 and the value of 7 in 4,732. Now, we'll do it much in the same way as we did the first one. We're going to write the value out. The value of 8 in 80,402 is simply 80,000. And that is because if I write 8, there are 4 digits after it. So I write 0, 0, 0, 0. So this is ones and this is thousands. So that is 80,000. Okay, now the value of 7 in 4,732 is simply 700. And that is because if you have 7 here, there are 2 digits after it. Okay. There are 2 digits after it, 7 and then 2 zeros. And that is 700. Now, the product of the values is very easy to multiply this. Don't look at it and say, oh, 80,000 times 700. It's not a big deal. All you have to do is just take the significant digit 8 and take the significant digit 7, and you multiply 8 and 7, you get 56. And so push your 56 forward. I've taught you this method on the Magic Tuesday. Then you bring down all the zeros attached to them and add it to that 56, as you'll see. Okay, so and you get 56 million. It's as simple as that. You get some of this as your assignment, which is coming up right about now. So you have to copy this. Question says, write out the value of 6, 4, and 7 in 75,246,029. Second question says, find the difference between the value of 3 in 134,719 and the value of 7 in 6,702. And the final question says, find the product of the values of 2 and 9 in 21,790. I believe you're done writing the assignments. I'll be on hand in the next lesson to show you how it's done. It's time to hand you over to Uncle Popo for the General Studies lesson. Till I come your way, next time, remain wonderful mathematicians.